Okay, guys, this is a little bit of a Mathematica bonus feature because I just spent a lot of times playing with it, even though I should have been doing something else. I just wanted to show you guys that you can use Mathematica to calculate the Laplacian, or basically to solve Poisson's equation or Laplace's equation. So if you look, I'm still using the notebook that I did before, which is I took that integral of that charged rod. And I'm going to save the results of the integral as the potential. So POT is the potential. Again, that's what I'm plotting in all these plots. Here, what I did is I took the Laplacian, which is just a built-in function in Mathematica, of the potential. I had to tell Mathematica what L was, or else it didn't really know how to evaluate that, or at least it couldn't come up with a nice friendly function. So I said, let L equal 10. I could have changed that. You have to tell it what variables to take that second derivative, which is part of the Laplacian, with respect to. So I said x and z, and then I multiplied it by the permittivity of free space. When I do that, I get rho, or the charge density. Okay, I just wanted to show you guys, as you would expect, here I'm at x equals 1 and z equals 2, so I'm not on top of my charged rod. So I'm in space here. Let's see if I can do this right. I'm somewhere, right? X equals 1, z equals 2. So I'm somewhere around here. Okay. I can look at how the potential is changing at that point. It's almost looking, right, like a quadratic function. So I'm going to take the second derivative of that. The first derivative will give me right, the slope is changing maybe linearly. And then if I take another derivative of that, as expected, when I'm not on top of my charge there, I get a very small number for the charge density, essentially 0. Okay, but if I put myself right on top of my charged rod, I actually get indeterminate, and that's because the charge density right on top of that rod goes to infinity, which is why we're using delta functions. Okay. The bonus feature here is to show you guys that you can use Mathematica to do an integral with a delta function in it. So you could use Mathematica to check the answers on your homework. You might have to look at the documentation to figure out how to do a multi-dimensional Dirac delta function. But if you are using Mathematica to check your answers on the homework, I still want you guys to show your work. So show me that you understand how to actually do that integral. So do it step by step. Include several steps in each of these integrals, like pulling out what ends up being constant because you applied that Dirac delta, so that I know that you understand it. But it might be nice to check the answers with Mathematica.